All right, for these problems, they're all on the unit circle. I know that because I have my unit circle page with me. We're going to see the degrees and radians that are going to be asked on this example or ones that are found right on this unit circle. So have this page and our definitions pulled up. I'm going to be using both the definitions I've got it circled here and this entire unit circle, not just the ones I have highlighted. The whole unit circle is where I'm getting my answers from for our example that we're working here. On this page, everything's on the unit circle because if I have that page in front of me, that unit circle, I can see that 45 degrees is on there. I can see that pi over 3 is on there, 2 pi, all of that stuff. All of this is on the unit circle. So that means that r is equal to 1. That's what the unit circle means. It means we have a radius of 1. That's just the definition of a unit circle. I know, because I've got that handy sheet that has all the definitions of the trig functions, that the cosecant is 1 over y, it's r over y, but remember r is 1, and the cosine is x over r, but r is 1, because we're on the unit circle. So I'm just going to rewrite that as x instead of x over 1. On my unit circle, I'm going to go to 45 degrees. I see that when at 45 degrees, y is the square root of 2 over 2. I'm going to go to 30 degrees. I see at 30 degrees that the x is the square root of 3 over 2. I'm going to simplify this a little bit. I'm going to do the keep, change, flip rule that we already looked at. And that's for this fancy fraction. I keep the numerator, change the multiplication, and flip the denominator. I don't have to do anything to the other one. Just leave it. And I'm going to be left with 2 square roots of 2 plus the square root of 3 over 2. And you're more than welcome to stop right there. You can stop right there. I am going to show you how my math lab's going to handle this. They are going to rationalize the denominator, but like I said, you may stop right there. What my math lab's going to do is try to get the square root out of the denominator in the first term. So it multiplies the numerator and denominator by the square root of 2. I don't have to do anything to the second term because there's not a square root in the denominator. I get 2 square roots of 2. And then the square root of 2 times the square root of 2 is just 2. Haven't done anything to the second term. And my final answer, since they both have the same denominator, since they both have the same denominator, I can write it like that. You do not have to go that far. You can stop way up here with the square root of 2 in the denominator. You do not have to rationalize. Now, I know several of these say you try it. I am going to let you try them, but I'm going to do a couple of them first. All right, so let me do a few of these, and then I'm going to let you guys try 2 of them as well. Remember, stop, rewind, rewatch, and get down any of the notes that you need. Because I'm going to erase, and I'm going to go try 2. I'm going to do 1, 2, and 3, and let you try 4 and 5. So I'm going to go a little bit out of what it says. All right, example 2 here. 2 times the cosine of pi over 3 minus 5 sine of 2 pi. All right, so I know that the cosine, the cosine is, actually, let me write it up here. The cosine of theta is x over r, but in our case, r is 1, so that's just x. And similarly, the sine is y over r, but since we're on the unit circle, r is just 1. So it's just really x and y. My first angle is pi over 3. So on my unit circle, I'm looking at my unit circle. At pi over 3, the x value is 1/2. Then I'm going to go to 2 pi. At 2 pi, the y value is 0. So I kept the 2 in red. The cosine at pi over 3, the answer for cosine pi over 3 is 1/2. Minus 5 Sine of 2 pi, I have that written in blue, is 0. So I've gotten rid of, I've done the part where I found the trig functions and put in their numeric answer. Now I can simplify this. 2 times 1/2 is 1. 5 times 0 is 0. So my answer is just 1. I told you I was going to do one more. So let me do 3 down here. Cotangent. The cotangent of any angle, theta, is going to be x over y. So now I need to figure out where 6 pi is. If you look at your unit circle, there's not a 6 pi on here, but I know I talked about it already, about how the unit circle or any circle is eternal. I talked about like Valentine's Day, they'll have like eternal bands, or even a wedding band, they'll talk about how the circle lasts forever and ever, so we can keep going. And we saw this a little bit in our very first section as well. We start on that x-axis. If we go all the way around, that's 2 pi. Then we can go around again, that's 4 pi. And we can go around again, that's 6 pi. So every even pi, 2, 4, 6, 8, 24, 36, 146. All of them, any even number pi is going to end up back at 2 pi. Or at 0, however you want to think about it. It's the same radians there. So we're over here at that point right there. So this is the point 1, 0. So in that case, x is 1, y is 0. We type that in our calculator, we get an error because we can't divide by 0. So we have an undefined answer. All right, now's your time to try these remaining 2. So I want you to pause and try 4 and 5. All right, let's see how you did. So the secant of theta, using that definition, the secant of theta is r over x, but since we're on the unit circle, that's 1 over x. And the cotangent of theta is going to be, that's the one we saw just a second ago, x over y. I'm going to keep 2 the same, but then I'm going to find the secant of pi over 4. So I'm going to go to pi over 4, that's in the first quadrant, and 1 over square root of 2 over 2, plus 4, the cotangent at pi over 3, going to pi over 3, the cotangent is the x over the y. Now I'm going to do some reducing. We keep, change, flip. And the same thing for blue. We keep, change, flip. Keep reducing. If you can do this in less steps, that's perfectly fine. I'm not going to skip any steps right now. These 2's do cancel out. I guess I'll skip that step. And then last, I get 4 square roots of 2, plus 4 square roots of 3. And we're going to leave it just like that. We are not going to worry about trying to rationalize that denominator at all, like we did the other one up above. That's a whole different ball game when we got those 2 different square roots in there. So just leave it just like that. Let's see how this last one went. It's similar to the example above it, except for this is negative, so I'm going to be going down. So I'm going to go down. This is going to be negative 1 pi. All the way over here is going to be negative 2 pi. And around again is going to give me negative 3 pi. So that's going to be over here on the left-hand side x-axis. The even numbers are where we're starting with on the unit circle. The odd ones are on virtue the left. So this is the point, negative 1, 0. And the secant, I think we had secant just a second ago up there, but the secant of theta is r over x, but since we're on the unit circle, that is 1 over x. So I'm going to have 1 over x is negative 1, and 1 over negative 1 is just negative